So you want to learn how to do input-output with files in C++. Let's try writing two different programs. The first program will be a program that opens a file and reads from it and then prints the content back out to the terminal. And the second program, you run from the terminal. It reads in some data that you type in, a string, and it'll write it out to a file that you've specified. In order to do this, we'll need a terminal and a text editor. So let me get my terminal ready to go. I like to keep everything organized, so I'll make a directory for my work. Of course, this is for CPSC 120. And let's call the first program cat. The reason I'm calling it cat is because there's a program on your in your terminal, in the shell on Linux, called cat that will concatenate a file to the terminal. So we'll just call it cat. You can call it whatever you want. Open it up in Visual Studio Code. So we've got our terminal, we've got our text editor, and let's start programming. So we first start off by providing the pound includes that we need. Well, we do need to have IOStream so we can print messages out to the terminal. We're going to work with strings, so we want a pound include string. We're going to use command line arguments because we want to specify a command with a file name as one of the arguments, so we'll need to use a vector. And then finally, here's the new thing, we want to use fstreams. Fstreams, spelled F-S-T-R-E-A-M. Fstreams are how we do file input-output. If you want to learn more about fstreams, a great place to look is cppreference.com. And you can find this. Let's make this text bigger. I guess I can't make it bigger. There we go. You can find fstreams under stream-based input-output. So if you select stream-based I/O and you look around, you can see that they have basic IF stream, that's our input file stream, and basic OF stream, that's our basic output file stream. So input, that means reading. Output means writing. So we'll be using the IF stream first, and then afterwards we'll use our OF stream. Again, that's the place you should look to learn more about these things, aside from like looking at your textbook or whatnot. Let's make a main program, or a main function I should say. We are going to be using command line arguments, so we want to type all this out. Now, I made another video earlier about how to use snippets, so if you have a snippet to generate this, it'll save you some time. Our next step is to get the arguments into a vector so we can process them. And the way we do this is we tell it we want to read in argv and go all the way to the end of argv by saying argv plus argc, and it will take in the command line arguments and stick it into that vector so we can get to it. Now we know that we're going to run, the way we want to imagine that we run this program is, let's imagine that we compile it and it's a.out. We want to provide a file here on the command line. So this would be arg at, let's see, that would be 0. The 0th one would be a.out, and 1 would be file to read. So we want arg at 1. So we need to make sure that we have at least 2 arguments in our arg vector. So we want to check that before we move on. So if our arg's vector size is less than 2, we know we have too few arguments. And we should print out a nice error message. Please provide a path to a file. Exiting. Just so they know that they ought to provide a file name, and we'll return something other than 0. Return 1 would be a good choice here. Now if we get past this if statement, this is where we can then say, okay, the command line argument has the name of the file that we want to open, so why don't we put that into a variable with a easy to understand name. I'll call it input file name, and we'll initialize that with args at 1. Whoops, typo. There we go. Now before we move on, I like to do things incrementally. I've written like 14 lines of code so far. So why don't we compile this, and let's put a return 0 at the end, and why don't we print out a message to ourselves so that we can see we're making some progress. How's that sound? So I save this. Now you can use the menus, but I'd recommend learning the keyboard shortcuts. So this is Control S, so I'm going to remember in the future Control S will save. And I'll come over the terminal, and I like to have the windows positioned so that I don't have to move them around too much. Let's compile our code. Remember, in this class we're using the C++ 17 standard, so it's a good idea to specify that. Now, if you forget to do that, it's not a big deal. You can see no news is good news. It's got an a.out there. And if we run it without any command line arguments, it does exactly what we expect. And if we go to file name, gosh, I don't have another file here. Oh wait, cat.cc is a file, so let's see what happens if I do that. Cool. Well, what would happen if I give it an imaginary file name? Imaginary file name. So that doesn't exist. You can see it still gets that information. Our next step is to say, well, let's try to open the file, and if the file doesn't exist, well, we should handle that as an error. So you can leave this in. We'll just comment it out. We don't need that anymore. That was a nice little way of testing our progress. Let's make an input file stream. So the way we do that is, again, it's in the standard namespace, ifstream input file stream, and initialize it with the input file name. Now remember that the file name isn't the file, it's just the name. So we give the name to input file stream, and input file stream talks to the operating system, and it somehow magically opens the file, and we're able to talk to that file through the input file stream. The file name itself is just the name. It's not the contents, and what we want to do is work with the contents. So that's why we need this extra thing, the input file stream, to manipulate that data on the disk. So once we have done that, that line actually tries to open the file. Now if it's successful, the input file stream will be open. If it's not successful, we can ask it. So we'll say if not input file stream is open. So if it's not open, we'll be able to figure that out, and we could print a message and say, uh-oh, could not open the file, input file stream. And we want to return 1 here. We don't want to continue. We want to stop the program. So why don't we, here, I'll uncomment this, and we'll try it out. We'll see what happens. Oh, and the other thing to remember, if you open something, you have to remember to close it. So why don't I put that in right now? What I'll do is I'll throw in the close at the bottom, because if you open it, you should close it. Now the only way it would get to this code is that it successfully opened it. Otherwise, it would exit over here because it never opened the code. So I'm going to save that, come back over here, let's compile this again, using the arrow keys to go back through my history. Uh-oh, what did I do? So remember, if you run into errors, you scroll back up and you start with the first error. Don't panic. It's probably something obvious. Ah, here we go. Alright. So invalid operands to binary expression. Oh, right, because I didn't mean to put input file stream here. I meant to put the input file name. There we go. Because I want to print out the name of the file. So I save that. I'm going to recompile. Great, now it works. No arguments, prints an error message, exits. I give it a file that exists. What files exist? Well, the file cat.cc exists, so we can try that. Oh, I misspelled it. Okay, so it opens it, moves on. What if I give it an imaginary file name? So this is something that clearly does not exist. And it will say the input file is imaginary file name, but it could not open imaginary file name, which is what we expected. So that's good. We're making progress. So, got the command line arguments. We can comment this out again. We got the file open. That's this line 16. We check to make sure it is open. That's this if statement between 17 and 20. Now our next goal is to read the data into a temporary variable, and we call this a buffer. It's just a place where we can store something temporarily so we can work with it. And because the file has many lines or many things inside of it we want to loop, we're going to want to loop through it so we can read it letter by letter, word by word, or line by line. In this case, I want to go line by line. So I'll use a loop, a while loop, and I can ask the input file stream if it's good or not. And a file stream is good when it still has data to be read from it. So when we reach the end of the file, it'll no longer be good and it'll stop the loop. But while we're in the middle of the loop, while we're in the middle of the file or the beginning of the file is considered good and I can continue reading from it. Let me declare a buffer here. It's going to be a string, and I'll call it line buffer because it's meant to be a temporary variable that's going to hold one line of text. And the way I read that one line of text is using the function getLine. And I read, and you might say, how do you know how to use getLine? Well, what I do know is if I come back over to cppreference.com, if I look up getLine, I can go directly to it and I can see there's this documentation, and the best part is at the bottom, it'll give you an example of how to use it. So I'm going to give you an example right now where the first parameter to getLine is where I'm reading from. So that would be the input file stream. And the second parameter is where I'm reading it to. That's going to be my line buffer. So to recap, getLine is a function that's part of the C++ standard library. And it's inside the string header file. It's going to read from the first parameter, the input file stream, and it's going to store what it reads into the variable that I put as the second parameter, line buffer. How far does it read? getLine defaults to reading all the way up to the \n, the new line character that we find inside of our files. Once I have read that line, I can print that line back out to the terminal. And getLine does strip out the new line character, so I put in that new line character. Let's save this. Let's compile it. Great. Compiles. And let's try to print out, well, let's double check. If I give it no parameters, good. If I give it a made up name, good. Now let's give it the name of the source code file. I should see the contents of this file printed back to the terminal. And sure enough, it does do that. That's pretty cool. So I have the program, and I give it the name of the file I want to read from, and I'll print it out. All of it right there. Now you might say, well, that's pretty cool. Can we try it with a different file? Sure. We can use Visual Studio Code to make a plain text file. Let's call it plain text. Or how about we call it something more interesting? How about we call it message.txt. This will open it up in Visual Studio, and we can write a message here. Hello world. This is a plain text file that I made with my text editor. And I'll save this. Let's Control S. And now it's saved. I can close it. And I can come over here, type ls, and you can see that there's the file message.txt. And let's try using our newly written program to print it out. Hey, it worked. So you can see it does read a file and print out the contents of the file to the terminal. So we're rather successful on this one. Now, before we move on, there's a couple other things that we could do in between where we're reading the file, which is lines 21 through 25, and where we close the input file stream, which is line 26. We can also ask some questions about did it reach the end of the file successfully, if there's an input-output error or there was some type of failure. So this is good to know, and it's good to have this available in case you want to check your work and make sure everything's working as you expect. So you can ask the input file stream if it reached the end of file successfully. And you can print out a message to yourself just so you can see that it did or not. So end of file, that's what EOF stands for. EOF stands for end of file. And if we can call this and it's true, that means it was reached successfully. Hooray! Another thing we can check is if the input file stream is bad. Just like we could check to see if it's good, we can also check to see if it's bad. That would mean there was some type of input-output error. I/O, that's how we shorthand for input-output is I/O. Error while reading. Because we're not writing, we're reading, so we know it's some type of error reading. And we'll return 1. Because remember, whenever we have an error, we want to exit with an error code other than 0. And let's do one other check. We want to check to see if the input file stream failed. That's another check we can make. And that, if there's a problem, it'll note to itself that there's some type of failure. Like it's kind of like the check engine light in a car, or some other type of alarm that you might have. And we can ask the input file stream if there was some type of failure. And if so, we can print out a message. Failure. And we don't know what kind of failure it is. I have a guess. Usually it's long lines, but we'll just put question marks. And we'll return 1. Now, with this extra code that we've added on lines 26 through 34, what this does is it will tell us if we've successfully reached the end of the file or if there was some type of error. So let's recompile the program. And let's try running it again and read message.txt. Cool. So you can see, you can see that it read the file and printed it out, and then it told us that it reached the end of the file successfully. So that's our program for reading a file and printing it out to the terminal. Now our next exercise would be to write something to a file, right? We want to create a file. Let's make a new file. Let's call this one, how about write message? So I'll use my text editor. I'll say code write message.cc. And the structure of this program is very similar to the program that we just wrote. So we can borrow a lot of code from that one. The difference is instead of using an input file stream, we're going to be using an output file stream. So let's write out all the pound includes that we need. So pound include, let's put that on the second line. Pound include IO stream, pound include string, pound include vector. Oh yeah, and the new one that we're using now, pound include fstream. So those are our header files. We need a main function. So we give, and we're also using command line arguments because we want to get the name of the file that we're going to be writing to. And at the end of it, we're going to say return 0. So I'm going to just put that in there now. Let's convert argv into a vector so we can use it, because we like using modern C++, not this old stuff. And we've done this a million times, but we'll do it one more time. There we go. Now we got our vectors. Again, same story. We need to have a command line argument. So we want to check to make sure we have enough arguments. So we're going to say args size less than 2. That means we have too few, and we'll give a message. Now, for those of you at home, are saying like, well, can't we just copy and paste this from our other program? Sure, you can copy and paste this from the other program, but I'm just going through the whole process again because, well, because you're paying for it. Now, if we get an error message, we return 1. Now, instead of having an input file name, we're going to have an output file name. So again, it's a string. I'm going to say it's an output file name. And the argument is going to be our first argument, because remember the 0th argument is the name of the program, a.out in many cases. And the second argument, which is location 1, is the output file that we're going to be specifying. And then we want to make an output file stream, not an input file stream, an output file stream. So notice that it has an O instead of an I. Right there, O instead of an I. We want an output file stream, and we'll call it output file stream because descriptive names are good. They help us make sure that we don't make errors. So output file name, and if, we have to check to make sure that we open the file. Output, let's spell that correctly. Output file stream is open. Well, I should say if not open, right? Because it has the exclamation mark there. If it's not open, then we know we had a problem. And I can print out a message. Could not open the file. Let's give the name of the file. Input. Oh, not input this time. Whoops. Output file name. Oh, and let's tell it we're exiting too while we're at it. Kind of long line. Anyway, and we return 1. Excellent. Now let's just put a little let's print out the name of the file just so we can check our work. Oh, not input. I keep on saying input, but it's output file name is. So I save this file. We can type ls and we can see that we've got this new file, write-message.cc. Let's try compiling it. Let's see if we're making progress or if we made any errors. It's always a good idea to write a little bit and compile. Don't write too much. Uh-oh. Boy, did I make mistakes. What did I do wrong? Let's see. Redefinition of args. Oh, whoops. I meant to type argc right there. That's a typo. Now let's try that again. There we go. So if I run my program with no command line arguments, it says please provide a path to a file. Cool. If I provide a name for a non-existent file, make believe, well, it prints it out. And if I give it a real file name, cat.cc, it also is right there. Cool. So it got that far. Now it did open it. Let me check something. Oh, that's a scary thing that can happen. If you give a file name that already has stuff in it to an output file stream, it will delete it. So notice that cat.cc is empty. You don't believe me? Look. If I do ls, you can see that cat.cc is right there. But if I look inside of it using more, it's empty. What happens is output file streams will delete things. Now, thankfully, if you catch this, you can always, and it's open in your text editor, you can hit undo and it will save it, and it'll undo what it just did. Because output file streams will create a file and delete the contents, so be careful. Oh, and notice that imaginary file name that I made right there, it now exists because output file streams create files. So if I made that by accident, I can always delete it with RM, but be very careful with RM. You don't want to do that again. Here, let me explain one more time what happened. If I look inside of cat.cc, you can see it's got stuff in it, right? You can see that I can compile cat.cc because we just did that a second ago. And it's a program. It works. Everything's fine. But if I also compile the other program, write message, and I run that program and I give it a file like cat.cc, what will happen is, I'm not going to run it quite yet, what will happen is in write message that I just compiled, it will open the file right here, and when it does that, if the file exists, it will delete its contents. It will remove everything. So be careful with output file streams. Output file streams can delete your work. Look, this is the contents of cat.cc right now. You can see that in my text editor. I run this program and it'll delete everything inside of it. Don't panic, because you can always undo it if you have it open in your text editor. If you don't have it open in your text editor, remember, if you're using Git and you're checking in your work, you can always restore the work because you're using Git to track your changes. So that was just a friendly warning to be careful with output file streams that you don't accidentally delete your files. Anyhow, let's move forward. We've opened the file. We've got this structure. I don't need to have this there. I'll comment it out. All right, next challenge is I want to have a variable that's going to store the message that I'm going to get. I want to read in not a word, not a number, but a whole line of text. So I'm going to declare a string variable that will be a message. And I don't need to initialize anything because I'm going to put something in it. But if you want, you can initialize it to an empty string or whatever you want. And then I want to print out a message to the computer user. Type your message out, and when you're done, press enter. or return. I don't know. Whatever your keyboard says. You want to say enter, return, doesn't matter. My keyboard says return, so I'll say return. Now, how do we read in a whole line of text? The way we do that is with getLine again. So when we've done stuff with cin, remember if we do cin message, because message is a string, it'll read one word, not a whole line of text. It'll only read one word. So we don't want this. This will only read one word. Oh, I shouldn't say terminal, I should say keyboard, because that's where we're typing. So what we want to do instead is I want to use getLine. GetLine will get a whole line of text, so it'll read everything up to the \n. And where does it read it from? Well, it reads it from cin, the keyboard. I'm going to store it in the message. And then once I've done that, I've got the message into that variable. Before moving on, why don't we just print it out to the screen and verify that it exists. And remember, if you open a file, like we do right here, right here, you want to close it. So I'm going to put that down here before I forget. It's so easy to forget these things, and that's how bugs creep into your program. So if you open it, close it. So let's compile it. Oh, whoops. Let's compile it. I'm going to give it a name for the output file. You can call it whatever you want, doesn't really matter. Now we're going to type a message. This is a secret message. Great, so I typed this in and it printed this back out. And if I also type ls, you can see it created output file. But if I look inside of output file, you can see it's empty because I haven't gotten to the point where I'm writing it into it. But this is a great way to make small changes to your program, test your work, keep moving forward. Let's delete that file. Let's delete message as well. So we just got our source code. And now we can comment out this line as well. The next challenge is, how do I get that line that I just read in from the terminal, from the keyboard, into the variable message, into a new file? Well, remember, the new file I created right there on line 14. So now I need to figure out how do I write that string, that message, into that file. And it turns out it works the same way as cout. So you can just say output file stream, use the insertion operator, which is that double angle bracket thing, and say message, and end it with a new line character. That's all there is to it. That's how you write into an output file stream, the same way that you've been writing to cout. So it turns out cout is an output file stream, and cin is an input file stream. They're just special ones. Let's try this out. So I'm going to save this work. Come over here. We're going to compile. Where is the compile? Let's run it. I'll put the output in my output.txt. The message today is October 26. Okay, exited OK. Type ls. You can see there's a file called myoutput.txt. Let's use more to look at it in the terminal. And the message was stored inside of it. Pretty cool, right? So we got an input file. We got an example for how to read from a file. We got another example of how to write to a file. And in both cases, we're doing it line by line. And always remember, you want to close your files when you're done with them, and return 0 when everything works out fine, and otherwise return something other than 0 when they don't. Both of these examples have already been posted to the Canvas lab page, so if you want to take a look at them, I'll put a link in the description. And I hope this was helpful.